In today's video, we are going to be solving equations involving volume problems. So we're going to be given a volume formula and some information regarding the volume formula and plug numbers in and solve for the missing variable. So in the first problem, it says, given the volume of each of the following cylinders in terms of pi, find the radius and diameter given the height. Okay, so we have our volume formula for a cylinder. So what we have to do, we notice in number one, they give us the volume, they give us that, and they give us the height. So you have to plug in the volume into V, and we have to plug in the height in for H, and then solve for R, because that's what we're looking for. Pi is not a variable. Pi is a number, as we know, 3.141592, so on and so on. Okay, so that's what I'm going to do. I'm going to plug in 144 in for the volume, and write that over here. And I'm going to plug in the 4 in for the height. I want to do that a different color. Plug in 4 in for the height. So we have on the other side pi r squared times 4. All right. Now, with any equation, like we're solving any kind of equation, we want to draw a line down the equal sign. All right, so what's nice about this, okay, is that there's pi's on both sides. That makes our numbers fairly nice to deal with. You'll see why in a second. All right, so we're solving for r. That's what we're trying to solve for. All right, we want to leave r squared on this side. We want to get everything else, so we want this and this to come over to this side. So what we would have to do is divide both sides, because the opposite of multiplying would be dividing both sides by 4 pi. Now, why do I divide both sides by 4 pi? Is because I want these to cancel, right? I want the pi's to cancel, and I want the 4's to cancel on this side. So I'm just left with r squared. Now, what's nice about this is that also on this side, these pi's also cancel. So it just leaves me with 144 divided by 4, which is 144 divided by 4, which is 36. Okay. So I have 36 is r squared. All right, we can't get rid of the squared yet. All right, now remember, to get rid of a square, we have to take the square root of both sides. The square root of 36 is positive or negative 6, but we're only going to deal with the positive number. So it's your answer is going to be 6, which is going to be r. So our radius for this is 6. Now we know how the radius compares to the diameter in a circle, right? This is the radius, the whole thing. This is the radius, all right? The whole thing is the diameter. So the diameter is double the radius, so double 6 is 12. Right. So again, it's just plugging into the equation, plugging into the formula, and isolating the r. You want to get r by itself, so you have to divide both sides by pi, divide both sides by 4, and then take the square root afterwards. Okay, let's look at another type of formula. We saw a cylinder. Let's look at a cone. So in this one, they give us the cone formula. They tell us the volume, and they tell us the height. So the same thing with this one. We plug in for V, and we plug in this one in for H. So we have a formula of 75 pi, which is equal to 1/3 pi r squared times 9. I'm going to do some simplifying on this side. So I know what 1/3 of 9 is. 1/3 of 9 is, if you multiply in the calculator, is 3. 3 pi r squared. Bring everything else down. All right, so how did I get that 3 again? I took 1/3 times 9, which is 3. So we have 3 pi, or just do 9 divided by 3. That's the shortcut way I did in my head. So we have 3 pi r squared on this side, 75 pi on this side. So just like we did in the other one, we have to divide both sides by 3 pi in order to isolate the r. So the 3's cancel, the pi's cancel, and the pi's cancel over here. So I'm just left with 75 divided by 3, which is 25. That square doesn't go away, all right? So in order to figure out what r to isolate r, we have to square root both sides. Square root of 25 is 5. So my r is 5, and my diameter is 10, double the radius. All right, let's look at a sphere formula. Four-thirds pi r cubed, that's the volume of a sphere. Now this one, they don't have a height, there is no height in the sphere. It's a ball. So there is no height in that. So all we're doing is plugging this in for v. So in our equation, we have 288 pi draw my line down the equal sign. All right, so a little bit different here. What's nice about these, I'm going to get the pi's out automatically, okay? And then I'll deal with the fraction. So let me first get rid of the pi's, all right? Divide both sides by pi, and that'll make it kind of nicer for us to see with this equation. We could do this equation to solve it. So I divide both sides by pi, get those to cancel. So I have 288 equals 4/3 r cubed. Now, if I want to get rid of a fraction, in order to get rid of a fraction, you have to multiply both sides by the reciprocal. So when I multiply both sides by the reciprocal, that helps me cancel out the fraction. 4's cancel, the 3's cancel. Over here, 3/4 times 288. 3/4 times 288 is 216. So that's how I got 216. Or if you use your Desmos calculator, why don't we do that? So we have 3/4 times 288 is 216, right? Then we want to find the cube root of 216. Going back here, so let me write this down first. 216 equals r cubed. I want to get rid of this cubed. In order to do that, I have to find the cube root of both sides. Let me do this. So the cube root of 216 is, clear. Okay, 3 goes there. 216 is 6. The cube root of 216 is 6. So that's my r, 6, and the diameter is 12, double the radius. So that one's a little tougher to do because you're dealing with the fraction, but you multiply both sides by the reciprocal, and then you'll be fine afterwards. All right. So again, it's just plugging into these equations and manipulating the numbers afterwards. And in order to find your r, remember the diameter is always double the radius. So whatever you get for your r, your diameter is going to be double that. Okay. So work through these problems. If you have questions, feel free to reach out and let me know. And good luck. Thank you for watching.